Alright, friends and neighbors, it's time now to extend this topology. Now, the last video was on VLANs and switches and routers, so it sort of stands on its own. But what I'm going to do with this one is make a little bit larger topology, and then we're going to do a little bit of tunneling along with that. So this is where we started. I'm going to get rid of a bunch of this stuff because it's not what I want to do now. Whoops. Yeah, let's do this. Come on. Whoop, wrong one. Okay. So we don't need these items. So what I'm going to do is directly connect to my router like this. And so I'm going to create a series of routers because we're going to build a small routed topology. So again, I'm going to pick my 2811s. And I'm going to have 3 routers up here, so I'm going to have 4 networks. So we'll need another PC over here. Oops. And so the way that it will work will be that we'll have F0/0. And these 2 routers are going to be connected to each other. So they'll need to be on the same network. And then up here, we'll have this one and another router on the 3net, and then this router will be on the 4net. And you can see that I've got sort of a convention that I use, with 253 being on the left, 254 being on the right. And let's go ahead and continue our connections. And as you know, I like my F0s, or 0/0, or whatever it is, on the right, or I mean on the left, and then I connect F0/1 will be on the right. So there we go. Okay. So now it's just up to us to connect them, and I believe that we've already got this router configured. So we'll do a show run on this one here. We'll take a look at the interfaces. We're already done with this router. So let's work on router number 1 in the middle. And we'll do config T into F0/0. And we'll do IP address. Now the IP addressing is not the hard part, right? Although I always encourage you to make a diagram like I've done here, because it makes life a lot easier. If you put IP addresses and the interfaces that they go along with here, I can't tell you how much that'll make your life easier when you're trying to figure out what you just did. So we're going to do the 3net now, like this. The hard part in this topology will be the routing. Now it's not terribly difficult. I don't want to scare anybody off, right? But we're going to have to be working with static routing, and we're going to have to add routes to every single router. So let's finish up the 3net. 254. Like that. Whoops. Forgot the IP address part. Now we're on the 4net. Now 253. There we go. Now if I take a look at my routing table, and I'll actually do that. We can see that router 2 here is directly connected to the 3 and the 4net. Router 1 will be directly connected to the 2 and the 3, and router 0 will be directly connected to the 1 and the 2. That means they have very limited information as to the rest of the topology. So that's what we have to fix with our static routing statements. Now this PC, we're going to put it on the 4net. Yes, I see you. I see you. All right. Got visited by a doodle. All right. and its gateway is 253. Okay. So let's do 4.0.0.1, I think is what I made it. All right, so our job is to get all the routing to work. Now, I've done other videos on how this works, but essentially what we've got here is we've got two directly connected networks. The one net, right, and the two net. What I need is a static route for the 3 net and a static route for the 4 net. And the same thing is true for these guys. I need a static route to the 1 net and the 4. I need a static route to the 1 and the 2 over here. So I'm going to do this part kind of quick because you can look at the other videos to see how it works, why it works. Oops. But I'll talk through it as I'm doing it. So what I'm going to say is IP route, I need to go to the 3 net. The mask for the 3 net is this. How am I going to get there? Well, I'm going to get there via 2.254. That's how I get to the 3 net. That's this router interface right here. So it's an IP address. That's really, really important. I'm also going to get to the 4 net that way. Okay. And if we take a look at my routing table, that's not going to work. There we go. So now I've got two directly connected routes, the 1 and the 2, and then I've got two static routes for the 3 and the 4. On router number 1, it's right in the middle. So sometimes I'm going to go that way and sometimes I'm going to go that way. So to get to the 1 network, I'm going to go via 2.0.0.253. That's the router that's going to help me out. To get to the 4 network, I'm going to go via 3.254. That's how I get there. Okay. Well, that does it for that. Let's take a look at router number 2. And in order to get to the 1 net, way over here, or the 2 net, both times I'm going to go via 3.253. There we go. And same thing for the 2 net. We take a look at my routing table. So all 4 routers, or all 3 routers, now should have 4 routes. And let's see if this works. Whoops. That's not what we want. There we go. Now instead of going to the 2, I'm going to go all the way to the 4. Now there will be some delays for all the ARPing and everything else, but we'll see if it works. If it doesn't work, that means I screwed up my routing. There we go. The last one finally worked. So that was just all the delays, right? I had to ARP for my neighbor here. I had to ARP for my neighbor here. I had to ARP for this here. But now we're working. Now just for fun, let's see. Do these guys have trace route? They do. Okay. So, I forgot whether it was the regular trace RT or trace route spelled out on Cisco packet trace. And there we go. We can see exactly how this went. It went to this router interface, it went to this router interface, went to this one, and then finally to the destination. I can do the same thing on the way back. If I go the other way, like that, there we go. So this one goes the opposite way. This interface, this interface, this interface. There we go. Done. So that is a basic routing topology. And that's what you would have to do to get this working. Now you could turn on a routing protocol or something like that, but that is a basic static routing topology. It works the same way every time. It's really, really important that you use IP addresses of the neighboring routers and not things like interfaces. Okay, so in the time that we have left, let's do tunneling. Now the important thing to realize here is that we want to understand our routing. And if I take a look at the routing table for router 0, I know that I'm directly connected here, but the way that this works is this goes via 10.0.0.254. And this goes via 2.0.0.254. When we do tunneling, we're going to do a couple of things. We need to create something called a tunnel interface. We need a tunnel interface. This will be tunnel or tun 0. That's what I'm going to use. Okay. Now, in this case, tunneling, one way to think about tunneling is this super magic thing that's very confusing. Another way to think about it is that it's just tricky routing. When we create a tunnel, in this case we're going to create something called a GRE tunnel. All that we're doing is we're putting a wrapper around the packet. We're going to have 2 IP headers, and we're going to encapsulate the IP packet in a GRE header. And the reason that we're going to do that, or the way that we're going to do that, is by sending it over the tunnel interface. This is not much different than VPNs, except that we're not going to encrypt. So what do we need to do? Well, we need to go to this router. Well, we're going to do it on 2 routers here. Now, another important idea is that we are still using the physical topology. So, we still need the interfaces that are out there. We can't just magically create a tunnel going across here and skip the router in the middle. We're going to trick the router in the middle. So the tunnel is going to go, from here to here and back again. But what we're going to do is set up routing so that we go over the tunnel. The tunnel is still going to be tied to the real world, but by going over the tunnel, it inserts the interface. Okay, so let's do some configuration. So the question is, where does our tunnel start and where does it end? Well, we're going to have the tunnel start right here, and it's going to end right there. And it's going to be bidirectional. So we have to set up a tunnel endpoint on this side and send traffic over the tunnel this way. We also have to set up a tunnel endpoint on this side and send traffic back over the tunnel. Now you don't have to, but then it gets a little crazy. We do split tunneling and all that kind of stuff. We're not going to worry about that right now. All right, so config T. There are lots of interfaces on a router that you might use that don't have anything to do with the physical interface. So for example, I could do a loopback interface. I could do that. I'm not going to use that. That's a management interface. What we want is a tunnel interface, or tun 0. All right, you can see that my prompt changed. So I could give this guy an IP address. So I'm going to go ahead and do that. And we'll call it 5.0.0.0.1. Now what we're going to do is set up a tunnel source. Whoops. Well, actually, maybe we'll see what are our options here. Well, most of them, we're not going to do IP version 6. We are going to give it an IP address. We already did that. But we've got some tunnel commands. What we want to do is say, well, here is our tunnel starting point and here is our tunnel endpoint. So where is our source? Well, the tunnel source is actually going to be F0/1. It's going to be that interface right there. Okay? All right. Great. Where is the endpoint? And this is where we need our routing. We need our actual routing here. So our tunnel destination is going to be an IP address which is on this side of the network. So it's going to be 3.0.0.254. And in that way, our router knows where it's got to go to get to the end of the tunnel, and that's also why we need to be able to route to the 3net. That's really, really important. Okay, so if we take a look at our configuration, we now have this tunnel interface right here. Now take a look at that MTU. That changed because we're going to be doing a double encapsulation. It's not 1480 anymore because we have this additional header now that we're going to be using. Okay, so we've got a tunnel source and destination. Well, let's go to the other router. We'll leave this part up here, and we'll I guess we're not going to leave it up there. All right, so we'll do here, we'll do int ton 0 again, and we'll say IP address 5002, like that, and we'll say tunnel source, and the tunnel source right now will be F0/0, and I remembered my my normal style of doing things. So this is F0/0 and F0. Well, we can put that on there, I suppose. There we go. Okay. Now the tunnel endpoint for this router is going to be 2.0.0.253. So tunnel destination 2.0.0.253. Now, in using the 2net, that means that this router 2, needs to be able to get to the 2net. That's really, really important. Okay. And again, we take a look at our configuration. And there we go. Now, we might say that we're done with the tunnel configuration. But does it work? Well, the forwarding might work, right? I might be able to get to the destination still, but am I using the tunnel? And the answer is no. I'm not using the tunnel. I'm using the straight up routing tables that I had before. So the question is, how do I use the tunnel? And the answer is, I have to remove or change my routing statements. Okay, so let's think about what we got to do here. What we have to do is modify the routing to get us to use that tunnel. And so I thought about it and I said, well, let's actually clarify some things here. We know that I'm directly connected to the 3net. And I'm also directly connected to the 4net. Previously, what we knew is that I have a static route for the 1net via 3.0.0.253. And we are static to the 2net via the same IP address. So what I want to do is I want to take this routing table and I want to modify it. And I want to change this. I'm going to the 1net. The 1net is the one that I actually want to use. I actually want to use the tunnel because I need the 2net to get to this end of the tunnel on this side. So what I'm going to say is I'm going to do a static route to the 1net via, and it depends on the router that you have. So you're either going to do ton 0, some routers will let you say this, or the IP address that's the opposite end of the tunnel. So in this case, it would be 5.0.0.1. So I'll just put that up here just as a reminder. On this end of the tunnel, we have 5001 and we have 5002. So on this side, what I'm going to do is a similar thing. I'm going to modify how we get to the 4net. Instead, I want to go via either the tunnel 0 or 5.0.0.2, which is the other end of the tunnel interface. So let's do that. So I'm going to say no IP route 1.0.0.0 and then the via is, what was it, 3.0.0. Now you can get away with not putting in the whole thing, but I'm going to try to be really clear here. So I'm getting rid of this entry, okay? The one net entry right here. And instead, okay, all right, thank you. I may have already deleted it. Okay, and so now what we're going to do is, now we're going to route via, let's try ton 0. Ton 0, it's an interface. It doesn't like that. So what I'm going to do instead is say 5001, like that. Okay. So let's take care of router 0. So we come over here and we're going to do the same thing. We're going to get rid of one of the routes and we're going to go via the tunnel. So config T, we say no, IP route, the 4 net this time, because the 4 is what we want to go over the tunnel, or what we want to have go over the tunnel, like that. And then what we were using is 200.254. So it says okay, so I probably killed that one already, but it doesn't really matter. This is how you would do it. And now we're going to do IP route 40.255.0.0.0, and we know that it doesn't like this, so we're going to try the other end of the tunnel. Okay, so now if I take a look at my routing table, all right, I can see that I'm directly connected to the 1 net, directly connected to the 2 net. I have static routes for the 3 and the 4. The 3 is just going to go the same way it always does, right here like this. And the 4, though, is going to go over this guy, which we've defined as our tunnel. And then we've got the tunnel interface as well. And so what I'm going to do is, we're going to see if it works, first of all. We'll do a trace, and we'll compare the two sets of results. And we can see that the routing has changed dramatically. Now, that doesn't mean we didn't use some of these router interfaces. But what it means is we sent this over the tunnel. Well, what does that mean? So if we look at the other end of the topology, let's do our routing table here. Whoa. We can see that we've got our static routes, and in one case we're going to the 5 net to get to the 1 net. We've got our 2 directly connected routes, and then we've got our tunnel interface. And if we compare our trace routes, we can see that this is the one that we did before, right? And then when we did it again after doing the updates, we go to the tunnel interface. Well, what does that actually mean? Well, let's take a look at the simulation. And I am going to just ping now because we want to see a regular ICMP traffic. So if I ping, oh, I don't know, let's just ping somebody that's on the topology 2.254. We'll just see, because I'm not, all right, I can't get to the 2 net without this router, so we'll send it over there. And we'll take a look at our topology as it goes, right? There's the packet. There it goes. Now, when I take a look at this, and I look at the outbound PDU header, I can see that I've got, right, Ethernet type 2, IP, and then ICMP. That's normal. That's the way that it works under normal conditions. But we've got a tunnel set up here for when we go to the 1 network. I want you to take a look at this right here. We've got a protocol ID of 01. That means ICMP. That code is ICMP. So that's normal. But what happens when we do the exact same thing? We'll go real time here, get it done, simulation. All right, so now what happens if I go to 1.001 again? So this time we'll say 1.0.0. Whoops, 1, like that. And we'll just watch our simulation. There it goes up to the router. Okay, so clearly it works, but let's take a look at some of the steps along the way. So when we leave this router, we know that we're actually going to be heading over the the GRE tunnel. And that's what we want to pay attention to. If we take a look at this, we can see that here is Ethernet type 2, but there's IP, wait a minute, GRE, and then another IP header. This last one is the actual message that we sent. But when it gets to the router, what the router says is, wait a minute, when you are supposed to be going to that destination network, you're actually supposed to be going over the tunnel. So what actually ends up happening is the packet, this packet right here, the original IP packet, and the ICMP, right? And there's our protocol of 0.1, is encapsulated in the GRE. So this one is actually the endpoint of the GRE tunnel, right? It begins at this interface, ends at that interface. But take a look at the protocol ID. The protocol ID is now in hexadecimal 2F, which is the code for GRE. And we can see that right here. Now GRE is a small header, which is why the MTU didn't change by very much, right? It's just 4 bytes. And then we have the original IP packet encapsulated. So that is what happens when you tunnel traffic. We just get encapsulated here into a GRE header. Now we still got to learn how to get to the tunnel, and we know that we go via this router to get to the 2net, which is the other end of the tunnel. And then router 0 in this case detunnels the traffic and then forwards it on. When it comes back, the router says, where are you going? You're going to the 4net. Oh, I'm supposed to encapsulate that, send it across to the other end of the GRE tunnel. Well, I still need this router to get to the 3net because I go via this interface, but I'm going to add the extra header. Now, if I had a firewall here or an access control list, I might get right by that because if the access control list is looking for ICMP, it doesn't find it. Why? Because the packet is actually GRE. And so when we're looking for a protocol ID of 0.1, it actually finds a protocol ID of 2F. And there you have it. There's tunneling. Okay, so in this video, it was sort of a continuation of the previous one. We're getting a little long here again. But what we did here is we built a routed topology with our IP route statements, a straight up routed topology. And then we modified that to have a tunnel interface, which really just encapsulates things in GRE. Only when they're going to a particular destination. Everybody else is not encapsulated. And remember that sometimes it'll let you get away with pointing to a tunnel interface. Sometimes you got to use an IP address that's part of the tunnel. Well, that'll do it for now. And whether you're tunneling packets or just sending them straight across a routed topology, may those packets always get to their destination. And remember, it's networking. You can do this.